Hello everyone, I'm Pradeep Kumar Palaniswamy, and today I'm gonna talk about something that's often overlooked in automation, securing the way we handle the credentials. The session is called "The Last Secret That You'll Ever Hard Code," and I'll walk you through how we can protect our automation from hidden risks using the HashiCorp Vault. I've been, in quality engineering and automation architecture space for over 17 years, working primarily in highly regulated financial services. That means I'm used to operating in environments where a single, security slip, like an exposed API key, can have huge consequences, right? I've had the opportunity to lead enterprise-wide vault adoption initiatives, and what I've seen is that securing automation pipeline is not just about the compliance. It is all about building the trust in our systems and protecting the customer data. What drives me in the area is a passion for building secure, more scalable automation frameworks, right? And we often focus so much on the functionality, so much on the performance, so much on the coverage, but we forget to ask, are we storing and managing these secrets the right way? And if we are not, then that's the gap that we have where attackers are more than happy to exploit, right? So in this session, I'm not just going to show you a Vault as a tool. I'll take you through the real world automation scenarios where insecure secret handling is at a risk, and then show you two live demos, that real world use cases. The first demo A, will focus on how we use Vault in everyday lower environment automation. And demo B will show you a more advanced setup for production-like environments where compliance requirements are, very strict. By end of this talk, we all should walk away with a clear understanding of the risks we face, how Vault helps us eliminate those risks, and how we can take these patterns back to our own teams, right? All right. The next one. So before we jump into Vault, let's talk about the problem. Most automation engineers don't realize it, but our scripts often carry secrets, like I said before, API keys or database credentials or access tokens. And because automation is designed to run hands-free, these secrets often end up in plain text, embedded in test scripts or config files or CI/CD pipeline variables and whatnot, right? Where do these risks hide? Three most common places I would say is one is your test scripts and config files, sometimes hard coded right into the code. Anyone with repo access can see them, right? The next is the CI/CD pipeline variables. We assume they are safe, but they can still be exposed in logs or screenshots, or even in a misconfigured permissions, right? And the next I would say is the local dev or test environments. Developers or testers may store credentials in plain files on laptops, which are much easier to compromise. Now, why is this dangerous, right? So because all it takes is only one exposed secret to open the door for attackers, right? So if that secret is tied to a database, an API, or even a staging environment that has production-like data, you have essentially handed them a key, right? And in many industries, especially like the one which I work, the financial services, this is not just a technical issue for sure. It is a compliance and regulatory violation. You are at a risk exposing personally identifiable information, PII, triggering security breaches and facing potential fines if applicable, right? We have seen real-world examples where the threat actors found exposed secrets in public GitHub repositories and used them to access private data. So these incidents are not very rare. I would say like they are happening every day. You all might have seen it. And importantly, attackers don't even care if it is a test environment. If it is connected to something valuable, they'll for sure exploit it, right? So the takeaway here is in automation, secrets are everywhere, and unless we actively manage and secure them, we are operating with an open door to all these potential breaches. So that's exactly the problem HashiCorp Vault is designed to solve, and that's where we'll go next. All right, moving on to the next one. So now that we understand the risk of hard coding secrets, let's talk about how HashiCorp Vault changes the game for test automation security. So Vault is, I would say, essentially our central nervous system for secret management, right? So instead of having API keys, passwords, test credentials, SSNs, and tokens sitting in multiple places, like code repositories or Jenkins variables or even someone's laptop, we store everything in one secure encrypted location. So that means there is a single source of truth for all our credentials, right? One of the Vault's biggest strength is that it doesn't just store secrets. It can generate short-lived or dynamic credentials. Think of it like a hotel key card that expires the moment you check out. So in our automation pipelines, that means no more static passwords that linger for months or years. A test can run or request a secret from Vault, use it for just few minutes, and then it's automatically revoked. That this drastically reduces the window of opportunity for anyone trying to misuse that secret. Another powerful capability is environment specific access control, right? So in our demo itself, in demo A, which I'll show you shortly, we'll focus on a lower environment scenario where automation jobs need certain credentials, but we don't want every job to have a free access, right? So Vault lets us define app roles and policies that tightly control who gets what. Even in non-production, we make sure only the right team can get the right secret at the right time, right? So then followed by demo A, we have another demo B, which talks about a production-like environment where compliance requirements are very stricter. Here, the app role setup is even more fine-grained, ensuring that CI/CD jobs only access production secrets if they all meet the policy requirements, right? And every single access is logged. So if a regulator asks who accessed to the secret last month, we can easily pull the data instantly, right? The audit trail is not just nice to have in regulated industries, but it is an essential one, right? And Vault also integrates seamlessly with CI/CD pipelines. So instead of storing the secrets in Jenkins or GitHub Actions, our automation code just makes a quick call to Vault during the job, retrieves the secrets very securely, use it and moves on, right? So nothing gets committed to the code. Nothing sits around in pipeline variables and nothing is left behind for someone to accidentally find it later, right? So as we move into these demos, think about how this applies to your teams. So demo A is about reducing the risk, in everyday lower environment automation, and demo B is about meeting the toughest security and compliance standards in in production like environments. So together, they show how Vault scales from simple use case to enterprise-wide security. Let's jump into the demo. So let's fix a problem, where most teams quietly live with shared long-lived database passwords and test region, right? those credentials end up in config files or CI variables or even in screenshots. So they are very hard, to rotate and easy to leak, right? Now I have a demo here, and I have db underscore demo.js file. Uh, what it does is, it authenticates. First, it authenticates to Vault using an app role. That's a machine identity. That's safe for CI and automation, right? And the second is it asks Vault's database secrets engine to mint a brand new Postgres user just in time for this run alone, right? And then the third is it connects with that user, then waits for the lease to expire and tries again to prove the user was revoked automatically. And right here we log in with the app role, and then um, we have this iTest role. Think of us like a pipeline proving who it is. So Vault returns a short-lived token, so we never hardcode tokens. Vault issues them on demand, right? And this call the database creds iTest role. Vault talks to Postgres and creates a real database role on the fly, so with a strong password and a TTL, time to live. And when the TTL expires or ends, the role is revoked automatically, right? So let's try it in action. And if you look at this one, so we are logged into the Vault and we have been issued an ephemeral DB user with short TTL. So we can see the expiry quickly. While we are waiting for the token to expire, let me explain what's happening behind the scenes. Right now, Vault has dynamically generated a set of database credentials for us. These are short-lived, meaning they are valid only for a fixed period. In this case, I've used, I think, 70 seconds. Yes, where is it? Yeah, 70 seconds. And this one, this is one of the Vault's strongest security patterns. Instead of having long-lived credentials sitting around in config files or hard-coded into code, we request them on demand, and Vault hands out a fresh set every time. And once the time to live or TTL runs out, Vault automatically revokes them in the database. So that means even if someone captured these credentials right now, they would be useless in just few seconds. So in real world deployments, these TTLs might be 30 minutes or an hour or even shorter for high security environments. The important thing is you don't have to remember to rotate them, right? So you don't have to store them. So what we are I think it just expired and gave us a message as expected, expired, user failed. That's what we got. And what this means is, for a team, no more static database passwords in code or CI. So every run gets a least privilege access, that gets self-destructed, and rotation and cleanup are automatic. And every credential request is audited in Vault for compliance. So this, one shift removes a whole class of secret sprawl from the test automation. Now let's move on to the next demo, demo B, and take a look at the data protection. Sometimes our tests need to handle values that behaves like a PII, say an assistant, right? So code paths are realistic, but letting lower environments store or print plain text is a policy and a compliance nightmare, right? So we set a lower environment policy that can encrypt only, and a prod-like policy that can encrypt and decrypt. So this script, logs in as lower first. It sends a sample SSN to Vault's transit engine. So the transit, doesn't store the data. It's encryption as a service. So Vault, returns the ciphertext and prefixed with Vault v1, right? And that ciphertext is what the lower will use in logs and artifacts. So safe to store and safe to transmit. And then lower tries to decrypt and gets blocked by the policy. Even if a lower runner is compromised, the attacker only gets the ciphertext, right? And finally we switch to prod-like identity with decrypt rights. So same ciphertext in, but plain text out. So under strict controls and fully audited, right? Let's quickly run it. And you see that encrypted SSN returned as Vault v1, that's lower doing the encrypt only, and decrypt blocked in lower with 403 as designed, I would say. And the production like decrypts, okay, we get the original value back from the back for the approved checks. So that's the beauty here. It's the separation of duties. A lower can process data, but never possess a plain text. Only the right identity in the right environment is allowed to decrypt. So every encrypt and decrypt is logged in Vault's audit trail. So we can answer who accessed what and when. Exactly what the auditors want. So let's put together with demo A. We have now seen two high impact patterns for the automation. So ephemeral access to the infrastructure, no long-lived passwords, and the second is the privacy by design for any sensitive data. Encrypt where you develop and decrypt only where you must, right? So both the patterns keep your teams fast and your pipelines clean, and of course the auditors happy. Let's move on to the next one. Before we look at how Vault helps, let's talk about the reality without it. First, we often see hard-coded secrets in the automation scripts. So this is a critical security risk. If that script is ever leaked, so are the credentials, right? So second, the secrets that make their way into Git history are almost impossible to erase completely. Even if you delete them in the latest commit, older commits or the folks can still reveal them, right? So third is storing secrets unencrypted in configuration files or environment variables is like leaving the keys under the doormat, right? So anyone with access to the system can potentially grab them. And the other thing is when credentials are shared across teams, there is no clear accountability. So if something goes wrong, it's impossible to trace who used them, right? And Finally, long-lived tokens or passwords are attractive targets for the attackers, right? So the longer they live, the more time an attacker has an option to exploit them. So this is exactly where Vault steps in. It enforces short-lived secrets, centralizes the management, and gives us secure access control, so we can avoid all these pitfalls. All right, let's move on to the next one, the benefits. So when we talk about test automation, one of the biggest security gaps we see is how secrets are handled, right? Like we have seen before. Um, this risk, this is risky, storing the credentials in config files. If the code is pushed to a repo, even a private one, so it can be exposed. So Vault, like I explained, Vault eliminates this risk completely. And with Vault, credentials never live in the code. Instead, our automation simply calls Vault during the test execution and retrieves the secrets securely. And it also dynamic, short-lived secrets. Static secrets are like leaving your like I said before, the leaving your house key under the mat, right? And we have the centralized management and CI/CD integration. So Vault acts as a single source of truth for all environments: dev, QA, staging, even production validations. So instead of juggling multiple credentials, stores, everything is centralized and controlled. So this also integrates seamlessly into our CI/CD pipelines. Jenkins, GitHub Actions, Azure DevOps, and you name it, right? So that means no matter where our test runs, the process for fetching the secrets is identical. And the other is granular access control and also the auditability, right? So we can define exactly which team, service account, or the test suite can access a specific secret, nothing more, nothing less. And every access is logged. This is a huge for compliance, because if something goes wrong, we can trace exactly who accessed what and when. So for example, in our every time Jenkins requests a secret, that action is logged in Vault, giving us a full audit trail. By combining all these benefits, no hard-coded secrets, dynamic credentials, centralized management, or tight access control and complete visibility, Vault gives us a secure, scalable, and automated way to handle the secrets, especially in the test automation. It is a security best practice that also, saves engineering time. All right, let's move on to the next one, challenges and best practices. When adopting Vault for test automation, the benefits are huge, but so are the challenges if it's not implemented, thoughtfully, I would say. Over the past few months, we have seen where teams can get stuck, and through our demos today, I'll also show you how we have addressed these pain points in our automation pipelines, right? The first hurdle is the initial learning curve. Walls concept like authentication methods, namespaces, and policies can feel complex at first, especially for teams coming from static credential management, right? And the second is managing the access across environments. The second, I would say, is managing different environments, dev, QA, staging, and pre-prod without risking cross-environment credential leaks, right? So in our setup, we used Vault namespaces and dedicated secret paths for each environment in demo 2, right? Sorry, demo B. This means a staging job cannot, you know, accidentally fetch a product secret, something we'll walk through, we walked through in our demo. And the next is handling network latency or downtime in CI/CD. So Vault downtime or network latency can block an entire test suite. So this is a real risk. So um, you know secrets are prefetched and cached securely for duration of the pipeline is a good option, minimizing the dependency on live calls during the test execution, right? And balancing the security with speed. There is a tension between strong security and fast automation always. Dynamic short-lived secrets are secure, but they require extra calls to the vault. So, I think in demo A we addressed this by setting a short-lived TTLs for high-risk secrets. Um, you know, but also caching the low-risk test credentials temporarily for faster runs, always with the audit log enabled, will help us. And the best practice, use vault namespaces or dedicated paths for the test automation, and implement least privilege access with short TTLs. Even if in case it is compromised, a secret is useless after a short time, right? And integrate Vault agent or sidecar for the automated retrieval, which removes the need for manual secret fetch logic in tests. And the other thing is rotate secrets regularly, even in non-production. Because the stale secrets, the test secrets are still at a security risk, right? And then we can say like the test vault failover in pipelines. So you don't want to discover a failover issue during the production release window, right? So by acknowledging these challenges early and applying these best practices, we have been able to make Vault a seamless part of our test automation pipeline. And as you'll see, as you've seen in the demos, these are not just theoretical. They are running today in our Jenkins build, ensuring both security and speed. Thank you all for your time. I hope this session gave you some practical insights. Um, you can take it back to your own projects. So if you would like to continue the conversation, share feedback, or discuss ideas further, please feel free to connect with me on LinkedIn. The link is right here on the slide. I'm always happy to exchange thoughts and of course learn from the community. Thanks again, and I look forward to staying connected.